Advent of Code Day 21, Dirac Dice. So basically I'm going to be playing a game here, but it's basically a deterministic game, obviously because I can figure out with programming. There's two players, there's a single dice, there's 10 spaces on the board, 1 through 10, and then when you go past 10, you go back to 1. Um, on each turn, a player will roll the dice 3 times, total it up, move forward. So in this case, like if they roll 2, 2, 1, they would move 5 spaces. If they're on 7, they go 8, 9, 10, 1, 2. Okay? And then you increase your score by the base you stop on. So, in this case, they get +2. And you win when you get to 1,000. And for part 1, at least, we're using a deterministic dice, which has 100 sides. The first roll is 1, the second roll is 2, the third roll is 3, and after 100, in which case it starts over at 1 again. So that's okay. That's useful. So the puzzle input is just going to be both players' starting position, and we're going to roll until when somebody wins, we're going to multiply the losing player's score times the number of times the dice was rolled, and that's it. So let's jump over here into Python and we'll get started. Game day 21. Got our stub here. And 21 input. Let's see. So basically we can just do. Let's see. What's the easiest way to do this? P1 equals player 1 equals line 0 dot split on space -1. I bet we could do this as a map function. Might be fun to just try that. -1 and then I think just int like that. Again, we could also do this as a loop, but it feels kind of silly. Although this is kind of silly. I'm down for it. So let's figure it out. Python 3 minus I day 21. 21. It doesn't matter which one we choose here. So this work. P1 is 3. P2 is 5. So that worked great. What if we were to say, let's get rid of that and do f.readlines. If we map string dot split on space is the default, so we can use it there. That will like that. We list that. Now what do we have? Yeah, now we'll have. That's not that. Now we're gonna have an array of arrays. But this is where list comprehension works really nicely, so we should just do that. So we'll do, if we do L for L in, and then for this, we're going to split it, and then we're going to take the -1, and then we're going to int it. And then, I think, let's see if we can do this, P1, comma, P2, or is that going to yell because of new lines? P1, P2. Ah, beautiful. Okay. Okay, so we got our puzzle. We got our input red. We can start with scores. So we can call it S1, F2 equals 0, 0. So both players start with 0 scores. So we have our scores in our position. And the last thing we need is our number of rolls. We'll start that at 0. So now we're going to play our game. We'll do while. Let's do while true. Seems fine. And what we're going to do, so the first thing we're going to do, player 1 is going to roll. So a roll is going to be rolls plus equals 3. Then, something we need to think of right away. Do we want to live in base 0 or base 1? The game board is base 1. It goes 1 through 10. But it's a heck of a lot easier when we start working with numbers to be in 0 base stuff. So what we're going to do is we're going to basically subtract 1 here, and we have to remember that. So now, when they start in 3, that means we're going to put them in 0, 1, 2, the third space. So we'll need that. Okay. So we're going to move roles is going to be plus equal 3. P1 is going to be plus equals roles. So if you think about a roll, when there's been 0 rolls, we're going to roll 1, 2, and 3, which is 6. It's also the same as third number, 3 times 3 minus 3. And the reason that works is because when you add 1, 2, 3, it's the same as adding 3 minus 2 plus 3 minus 2, 3 minus 1, and 3, right? So it's this last number 3 times, and then we subtract 2 and subtract 1, which is 3. So even if you do a bigger number, even if we're doing like 8, 9, I guess I could do this with pluses, plus 9 plus 10, that's really equal to 10 minus 2 plus 10 minus 1 plus 10. Or to be really fancy and do, this is, x minus 2 plus x minus 1 plus x. Well, that right there you can just say is 3x minus 3. Okay, probably too much explanation, but we'll go with that. So we're going to move forward by roles times 3 minus 3. And that way we can, so now we've effectively captured the roles. The last thing we need to do is roles. Let's see, if it's 100, we still roll 100. If it's 101, we roll 1. So that is, we just have to be really little careful. We could do rolls mod 100, but then if it gets 100, it returns 0. So what we really want to do, it's a little silly, but we can do rolls minus 1 mod 100 plus 1. And what that's going to do is basically it's going to give us, it basically is going to give us rolls mod 100, which is what we want. So if it's the 104th roll, we're going to roll 4. But if it's the 100th roll, we want to make sure we don't get a 0. We don't get 0, we get 100. So to do that, we subtract 1 here and then we add 1 there. So, okay, that should be fine. So now we're going to say, and that's not, and now we're going to say score1 plus equals P1. Also, we need to do this. Sorry, just this mod 10, because if you're on space 9, you go, yeah. Okay, and so it's plus P1 plus 1 because the spaces are actually 1 more. Hopefully that makes sense. I think that's it. I think we just solved player 1's turn. We do if S1 greater than, what are we playing to? 1,000. 1,000. We'll print part 1, and that is rolls times S2. I guess we can break. Okay, so now we'll be down here and we'll do rolls plus equals 3 again. Let's just yank this. Paste. Now we'll do player 2 is moving forward by rolls, blah, blah, blah. We'll do score number 2 increases by score by player 2's position. If that's the case, and then all we need to do is change this to a 1 and break. That almost feels too easy. Let's see let's see though. Just for, it won't take that long. 9, that does not look like the right answer. Dang. Let's see, what is S2? What is S1? Let's do if rolls greater than, actually, let's not. Let's just do some printing. After each one of these, we will print P1 S1 P2 S2 rolls. Paste that again. It's going to be a lot of printing, so I'm going to get rid of that and go into less. Okay, let's compare. So at the end of 1, I move to space 10. Fine, you have our score of 10. 7 for player 2 rolls, and now has moved to space 3 for a score of 3. That is not right. Okay, so that's we've already found an issue somewhere. So rolls was 6. That would be 18 minus is 15. Is that the right thing? Yes. Are we moving to space 3? So we should be in space 2. No. Okay, we found our problem. We missed a mod somewhere. Okay, so when we add P1, when we're moving P forward, we're doing our work to mod this by 10, but then we add it to P. So if P was 9, now we get 19. That's not what we want. What we really want is P1 plus that. So the P1 is now inside we get the whole sum, the new position, and then we mod it. Same thing down here with P2. That should work. Let's see, should, famous last words. Let's run it. 752, 247. Does that work? 752, not quite. What we should have, we should be on roll 993. So we're getting very close. Oh, so here's the problem. We're getting to exactly, I think, is it to win if you get 1,000 points or at least 1,000? I'm guessing that includes, is it as simple as that? 739,785. 739,785. Nice. Okay. Let's see if we got it. We did. Part 2. All right, now you're warmed up. It's time to play a real game. The second compartment opens and you get a Dirac dice. It's a single 3-sided die. When you experiment with the die, it's a little strange. It's a quantum die. When you roll it, it splits into multiple. The universe splits into multiple copies. Get kind of big here. 1 copy for each outcome. One word, 2. The game is played as before, although to prevent things from getting out of hand, the game ends we get to 21 using the same. Player 1 wins in that many that's a lot of universes. Player 2 wins in that many universes. Okay. Find out the player that wins in more universes. How many universes is that? So I need to count. Man, so every die roll is going to result in 9 universes, right? So 3 times 3 times 3. So it is going to get out of hand very quickly. That's why we're only playing to 21. This is like almost like a completely new problem. Let's see. We're going to treat it as a completely new problem. I don't see any much benefit to get all of this again. We will also get rid of our debug prints here. Okay, so we go back to scratch here, and we got our P1, P2, our rolls, etc. What we can't do is just a straight recursion, because recursion where we call all 3 options and we just handle all these universes because it's huge, right? What I think we can do is acknowledge that, like, okay, we're playing to 21, right? If player, doesn't matter how you get somewhere. If it's let's say it's player 1's turn and player 1 is in spot 20, all 3 of their universes, or it has 20 points, all 3 of their universes are going to return player 1. It doesn't matter how we got there. And so if we compute that, so for each game state, there's only one possible total number. There's only one possible set of results. So for the game state, it's player 1's turn. They're in spot number 20 and they're about to roll. Their game state will be 3 wins and 0 losses. And so now we can step back and we can do, okay, what if they're in 18? Well, sometimes they win in the next roll and sometimes they land on 19. And then we know what happens when they're on 19. If the next, we can figure it out. So if we track game state, we can reduce the amount of work we have to do significantly. So we'll do def turn I don't know if there's exactly like the word, which will take in a P1, a S1, a P2, an S2, and a player. So we need to know whose turn it is. So on your turn, what's the easiest way to like make this happen? We will. So let's just walk through. So we will. We're gonna have same kind of thing as before. We're going to get our rolls. We don't care what number of rolls anymore. That's nice. I guess we'll say if well, we need to move that player forward, right? So annoying, but okay, if player equals 1, then here we go. We'll do this. We'll do P equals P1 if player equals 1, else P2. In fact, we can do P comma S equals P1 comma S1, do X S2. There we go. So now we have our P. Okay, so what's gonna happen? We're gonna roll the dice 3 times. So we'll do 4 I in 1, 2, 3, the 3 possible outcomes. For J in 1, 2, 3. For K in 1, 2, 3. Now there's our die rolls. We're going to call. Let's see. Then we will do turn of. Oh, we have to figure out how to add. Okay, so we'll do. Oh man, this is like the silliest thing. What I'm struggling with is like I'm gonna add. Okay, so I'm gonna add these to P. But then how do when I call turn, I have to know which one to put P. I guess we can just do an if. Ugh, I don't like this. But so I guess we probably don't even need that first line then. If player equals 1, then we will do turn P1 this is not hard. It's just like messy about how to write it. So we'll do P plus equals just like before. No, we have not plus equals. P equals P plus I plus J plus K. We're gonna make our spacing look nice. So we're gonna add all that together. Mod 10 to get our new position. We're gonna do S plus equals P plus 1 to get our new score. And then we'll do if player equals 1, turn P comma S. Yeah, so this is unnecessary. Do this. That P1 comma S1 comma P2 comma S2 comma, and the player's turn will now be 2. And paste. Oops. Undo. Paste. And this will just be else. I somehow lost the other 2 lines. 2 yank yank. Paste. And this will be 2, player 2, player 2, player 2. And this will be 1. So we're gonna do a loop, and we're gonna end up calling ourselves all these times, 9 times each. Each one's gonna spawn 9 new calls, and the call is just gonna be we're gonna update the player who it is. We're gonna then call turn again for the next player. We have not reached a base state here. guess before we do this, I guess no, actually here, in here, if S1 is greater than or equal to 21, return, in this case, player 1 will have won 1 game and player 2 will have won 0 games. Otherwise, we're gonna need to keep like a sum here. Sum total equals 0, 0. And so here we can then do, we get this back, we can do win 1, win 2 equals that. And so we can do answer total equals total zero total. This is weird. Let's not make it total. Let's make it win 0 comma or win 1 comma win 2 equals 0 comma 0. And then how do I simply add the results to that? Feels like that should be easier than it is, but new win 2, new win 2, win 1 plus equals new win 1, win 2 plus equals new win 2. I feel like this is very ugly, but we're gonna go with it for now. Okay, so during player 1's turn, if they are going to move their spaces, if they've won, they're just going to return that they won. Otherwise, we're going to call again off this universe and get some new wins, totals, add them in, and add them in. We can do the same thing over here. If S2 is greater than 21, return 0 comma 1. Otherwise, next win 1, next win 2 equals that. W1 plus equals next win 1, W2 plus equals next win 2. And that looks pretty good. Now, again, the thing we have to remember here is we have to save all of this. So let's see. Do I want to use? There's a thing called LRU cache, which we could import from functools, or we could do it ourselves. Let's just try functools first. I think this is right. Functools import LRU cache, and I think we just come down here and put a decorator on this at LRU cache like that. It might be like that. We'll see when we get an error. And so there we go. So now all we have to do is, what are we, pass in our stuff. So we will do, the odds this works on the first time seems low, but let's just go for it. Let's do print, turn, P1, S1, P2, S2, 1. Okay, that didn't work. Oh, we never. Okay, so after we loop, we return. We've been returning a lot of zeros there. W1, W2. Still didn't get anything. Maybe return is not the right thing here. Because then we're breaking out of our entire loop if anybody crosses. Maybe we do this at the front. Shoot. Okay, so let's come down here and we'll try this again. So if p1 is greater than or equal to 21, return 1 comma 0. If p2 is greater than or equal to 21, return 0 comma 1. Get rid of it here. That seems cleaner. Let's try that. Maximum recursion depth. Dang. LRU cache might not be working. Let's do this manually. Cache equals that. And all we need to do then is, do I need to call this global? Probably global cache so that it's always there. And now whenever I return, I'm going to save it into the cache. So whenever I return down here, I'm going to say cache of, and we need our full state here. So we're going to do P1, P2, let's do P1, S1, P2, S2, player. Like that. So if that's the state, I'm going to set it equal to W1, W2. And then we can come up here and we can say if P1, S1, P2, S2 player in cache, return cache that. Basically, if we've already solved it, we just return it again. We don't need to loop. And that will cut off so many loops. Still not enough. Something is still wrong. File takes 20. Still hitting recursion. Okay, I'm just an idiot. I'm not looking for P1 is greater than 21. I'm looking for S1 is greater than 21. Could that have been my issue? That seems way too low. Yeah, that's not going to be it. Shoot. Let's see. What could we be doing wrong here? Ooh, okay. I'm changing. I think. Yeah, okay. Let's see. We're gonna do this. We don't want because we don't want to actually change P1 and S1 on these loops. We're gonna do new P1, new S1, new P1 here, which is not, yeah, okay, that's good. So we're gonna add P1 to the die roll. We're gonna get a new P1. We're gonna add new P1 plus 1 to S1 to get new S1. We're gonna call the turn new P1, new S1, P2 and P2 have stayed. P2 and S2 have stayed the same, so we're fine there. Down here, we need to say new P2 is new S2. Now it includes that, and now we include new and new. Let's try that. Reference before assignment. No. Okay, equals S1 plus, because we don't know new P1 there yet, right? So we need to just do new S2 equals S2 plus new P2. Ooh, we got numbers. We got big numbers. Big numbers are good. And we got big numbers really fast. So let's pull this back up. Let's see. Can't even tell that. That looks good. That looks good. Okay, so what are my answers going to be? Find out the player that wins in more universes. How many universes does that player win? So all I need to do is print f part 2 equals that, and then we're just going to return max around that. That looks good. This is a good one. Let's see if we actually got it. Nice. Okay, that was a tricky one, and we got it pretty fast, so I'm happy about that. Let's see. What did we do? Let's talk this through again. Part 1. Basically, we are just playing the game out. We roll. We just have to track the number of rolls. We have to track the score. Back to that at the end. Remind me. I think there's something I can make this whole thing look a lot cleaner, maybe. We'll come back to that. So I'm doing the 3 rolls. I'm getting the sum of the 3 rolls. I am adding it to the old P1. I'm taking mod 10 to get my position on the board. I'm then incrementing the score, and if the score is greater than or equal to 1,000, I win and I'm done. And I just do the same thing for player 2 here. And then I can break on either time. That's pretty simple. So then I start over, and I got this new weird universe splitting version. And the secret here is the cache. If we didn't, I wonder if this has to be global. Humor me for a second here. Do I need to put that as a global? This is one of those things that I'm always kind of rusty on, but no, apparently not. Okay, so I decline this. I get this cache variable, and the whole idea is if I've called this exact board state before, I don't need to do it again. And we can even think about, we can talk through the number of board states that can exist. So player 1 can be in 1 of 10 spaces. Player 2 can be in 1 of 10 spaces. Score 1 can be anything from, I guess hypothetically, we could get all the way as high as, let's say you were in space. No, you landed on space. You were at 20 points and you landed on space 10, so you get all the way to 30, I guess. Let's just make that up. So same thing for that one, and then player could be 2. So that is 3 times 3 is 9, plus 4 zeros is 9, 2, 3, 4, times 2 is 18. I think that's right. So 180,000 board states, which is like a lot, but it's not, if we brute force through every, oops, I didn't mean to do that. It's not if we brute force, every game state where we're gonna have to play all these different universes over and over again, because that's a ton. And so by doing this cache, by saving, okay, if I'm in this game state, just return, I've seen this game state before, I've already solved it, throw it out and don't, just give me the result. That really is gonna make this solvable. So then if either player has won, we're just gonna return that player won, the other player lost. And then we're just gonna keep track of, and if nobody's won, we're gonna then go do branch and call nine new things, and we just need to keep track of who wins how many of those games. So I guess hypothetically we could just let's see. Hypothetically we could just track one of those. Let's see. Can I assert? No, I was gonna say, can I assert that W1 plus W2 is always equal to 9, but it's not, because it's 9 in the most base case, but each of those 9 could have many universes underneath it. So yeah, so I need to track both. So I start off with, for this loop, it's at 0 and 0. I do all 9 possibilities. If I'm in player 1, great. There's probably a way to clean this up, so I'm not doing this ugly print the code twice stuff, but we'll leave that. It worked. But basically, so, for each play, whichever player's turn it is, for each iteration of the loop, I get a new position, I get a new score. It's important that they don't overwrite the P1 because I'm going to need it in the next loop. And then I call turn on that new position and new score. And then the results come back with how many from that state, how many wins each player gets. I add them to my total and I continue looping. And then at the end, I make sure to update my cache and return, and then it solves very quickly. So that was cool. Whoa, I said I was going to come back to something. What was I going to come back to? Oh, I was looking at this right here, and I do a mod. I'm mostly just adding a bunch of stuff together and doing a mod 100 and a mod 10. And I'm wondering if this mod 10 basically makes this mod 100 unnecessary. So let's see. Yank paste, insert, comment that out. What happens if we don't worry about the mod 100 at all? And we just do rolls times 3 minus 3 like that, and then we have the mod 10 at the end take care of all of it. I have this like sinking this suspicion that this is still going to work, and it's not as clear to like know what's going on. So I kind of like the other way. But, I don't know. Is the other way actually clear? I don't know. Let's see. Miss a parenthesis somewhere. Yes. Don't need anything around rolls, and probably don't even. I probably can do that and just let order of operations handle it. Did I get the same answer? I did. So we could simplify these down a lot. Like that. Yeah, still works just fine. Cool. So in case I did that kind of fast, but basically because we're doing a mod 100, but then we later do a mod 10, if let's say I don't do this, right? So rolls is now 903. That's even when I multiply that by 3, I just have, or let's just make it simple, 103. When I multiply that by 3, I now have 303. But when I then mod 10 that, the 300 is going to fall away anyway. And so I don't actually care. And I don't even have to worry about this edge case where it's 100, because when it's 100, I am going to be doing 0 now because I'm doing mod 10. Whereas before, I wanted to make sure that was 100 and not 0. The mod 10 blurs all that out anyway, so I don't have to worry about it. So that's kind of cool, I guess. Okay. And the one other thing I wanted to check out before we stop for the day is functools thing. So I tried that at the beginning, LRU cache, but it failed, but my recursion was all broken at the time. So let's come in here and remove my cache. So we don't need that. We don't need that. We don't need that. And then at the end, we don't need that. So we're no longer caching. And we can just show that this runs really long. And, you know, again, this thing that ran in under a second is now, trust me, will run basically forever. So if we come back up here and we give it the decorator, let's see if I can remember how to do this. LRU cache, like that. Oops, did not mean to kill that. Let's see. So Python 3 day 21 input, and it's not caching. Okay, let's jump over to functools cache. Try that. And interesting. I'd never heard of this. I didn't know we could do cache. LRU cache max size equals none. Oh, neat. Okay. Is that a new? Am I in? Yeah. Okay. I don't think. Got cache. That's not a. Okay. That's not a thing. That's a 310 thing. I'm not running 310, so let's not do that. But we can do LRU. LRU cache and a max size. That's what we want. So we will do size equals none. Let's try that. Instant. Sweet. And that felt even faster than my original cache. We can time that. Looks like it's coming out around 0.16, 0.15, 0.16. So that was wicked fast. If we do that, if we get rid of, let's see how fast my cache was. It makes sense that their cache is more optimized for running. So, I mean, we're talking about 0.05 seconds, but it is faster. So that's kind of cool. Anyway, I'm really going to end this video now. Thanks very much for sticking around till the end, and we'll talk to you next time.